So this is all about the algebraic methods, and we are done with the algebraic methods. So let's just move on further and talk about the another topic, which is nothing but called as the equations which are reducible to the linear equations. Now we will do the questions that are related with this particular concept. So first of all, let us suppose I am having the equations which are of the form 2 by x plus 3 by y, which is equal to 13, and 5 by x minus 4 by y, which is equal to minus of 2. Now we just wanted to solve such kind of an equation. So is it possible that we can solve these equations with the help of the algebraic methods that we have done before? So yes, this is possible, or it is possible to solve such type of an equation in an interesting manner, because this is what our topic today, that we have to reduce such a type of equation in which the variables are actually occurring in the denominator. As you can see over here, in this particular equation, the variables are in the denominator. Similarly, in this particular equation, the variables are in the denominator. So for such kind of the equation, we have to reduce these kind of equation into the formation of linear equation. So let's just solve this or these pair of equation, and we can see how we can apply the algebraic methods over here in order to find the value of x and y. So let's just see both of these equation again. So first of all, we have the equation as 2 by x plus 3 by y, which is equal to 13, and the second equation was 5 by x minus 4 by y, which is equal to minus of 2. So first of all, we'll reduce these equation into the linear equation, and then we will apply the algebraic or appropriate algebraic methods over here in order to find the value of x and y. So for an instance, if we are talking about this very first equation, let us suppose I'm calling this equation as nothing but 1. So for such type of an equation, always remember we have to substitute the variables which are of the form of p by q as a capital A or as any other variable. For an instance, as we have 1 by x over here, we have 1 by y over here. So we will substitute 1 by x as capital of A and 1 by y as capital of B. For an instance, we are taking, let us suppose, let 1 by x is nothing but capital of A and 1 by y is nothing but capital of B. For both of these equations, I am assuming that 1 by x is actually capital A and 1 by y is nothing but capital of B. So it means that the equation number 1, or let us suppose I'm calling this equation as equation number 2, these two equations will be reduced in a manner, as you can see over here, we have 2 1 by x, so we can write it as 2 1 by x. Further, we can write the equation as 3 1 by y, which is equal to 13. So now you can see over here we have 2 into 1 by x plus 3 into 1 by y, which is equal to 13, and we have supposed 1 by x as capital A and 1 by y as capital B. It means we have to substitute 1 by x as nothing but A and 1 by y as nothing but B. So let's just substitute the value over here. We will get the equation as 2a plus 3b, which is equal to 13. So this is nothing but our equation, which is actually called as the linear equation. This is nothing but a linear equation now, because we do know that any equation which is of the type ax plus by plus c is equal to 0 is called as a linear equation. Now we have the variables as capital A and capital B over here. Now in the same manner, like we have reduced the equation number 1, we will reduce the equation number 2. So we have taken 1 by x as nothing but capital A and 1 by y as nothing but capital B. So it means we can reduce this equation as 5 into 1 by x minus 4 into 1 by y, which is equal to minus of 2. It means we can write this equation as 5 of capital of A minus 4 of capital of B, which is equal to minus of 2. Now you can take 1 by x as any particular value. You can take 1 by x as m, you can take 1 by x as small a. It is all your choice. So I am taking 1 by x and 1 by y as capital A and capital B. You can take any particular value instead of capital A and capital B. So the second equation will be reduced into the formation of 5a minus 4b, which is equal to minus of 2. Now let us suppose I am calling this equation as equation number 3rd, and I am calling this equation as nothing but equation number 4th. Now in order to find the value of x and y, we have to solve the equation number 3rd and equation number 4th. Now let's just solve the two equations, that is the equation number 3rd and equation number 4th. As we can see, we have the 4th equation as nothing but, let us suppose I am writing the 4th equation over here. We have the equation 5a minus 4b, which is equal to minus of 2. Now you can apply any particular method over here in order to find the value of capital A and capital B. You can apply the substitution method, you can apply the other cross multiplication method or elimination method. You can apply any kind of a method. So for an instance, I am using the substitution method over here. So let us suppose if I'll find the value of a from this particular equation, and I will substitute the value of a in the 3rd equation, as this was my 4th equation. So let's just find out the value of capital A from the 4th equation. So it would be 5a, which is equal to minus of 2 plus of 4 of b, and further we can write it as capital A is equal to minus of 2 plus of 4b divided by 5. So this is nothing but the value of capital A. Now let us suppose I am calling this equation as nothing but equation number 5, and I am substituting equation number 5 into the equation number 3rd. So let us suppose we are substitute equation number 5 into 3. So if we substitute the value of a over here, we will get 2 into minus of 2 plus of 4 of b divided by 5, further plus of 3b, which is equal to 13. Now let's just solve this. So 2 into minus of 2 is minus of 4 plus of 8 of b divided by 5. So if we'll take the LCM over here, we will get the answer as 5 into 3 is nothing but 15 of b divided by 5, which is equal to 13. So let's just take 5 towards the other side. So it would be nothing but minus of 4 plus of, we have this as nothing but 23 of b. Further we have 23 of b, which is equal to nothing but 5 into we have 13. So this is nothing but 65. So it means we are getting the value as 23b, which is equal to 65 plus of 4, which is nothing but 69. So it implies b is nothing but is equal to 69 divided by 23, which is nothing but 23 into 3 is nothing but 69. So it implies that the value of b is actually coming out to be is equal to 3. So hence at the end we are getting the value of b as nothing but is equal to 3. We are getting b as 3. It means we have to substitute the equation number 6 into the equation number 5 in order to get the value of a. So substitute equation number 6 into 5 in order to get the value of a. So capital A would be minus of 2 plus of 4b. The value of b is nothing but 3 over here. So this will be 3 divided by 5. So this is nothing but minus of 2 plus of 4 into 3 is 12 by 5, which is nothing but 10 by 5, and 5 into 2 is 10. So the capital A is nothing but 2. It means we are done with the value of A and B. Means capital A we are getting is nothing but 2 and the value of capital B is nothing but 3. But we just wanted to find out the value of small x and small y, because the only variables that are present in the equation number 1 and in the equation number 2 is nothing but small x and small y. So we just wanted to find out the value of x and y. So how we can calculate it? As we know that we have the capital A as nothing but 2, we have the capital B as nothing but 3. Moreover, we have supposed that 1 by x is nothing but capital of A and 1 by y as nothing but capital of B. So let us suppose if I am taking this equation as nothing but star, so we have to substitute the value of capital A and capital B in the equation star. So let's just substitute the value over there. So substitute equation number 6 and 7 6 and 7 in the star equation, So as we can see, we have 1 by x which is equal to capital of A, and 1 by y which is nothing but is equal to capital of B. So capital of A is nothing but 2 and capital of B is nothing but 3. So it will cross multiply, or it will exchange the position of these values. So we will get x as nothing but half, and we will have y as nothing but 1 by 3. Or we can say, if we have taken the reciprocal of all these terms, then we have x as nothing but half and y as nothing but 1 by 3, which is actually the solution for the equation number 1 and for the equation number 2. So this is all about the concept of reducing the equations of such a form into the linear equation and then applying the appropriate algebraic method to find out the value of x and y. So this is all about the equation reducible to linear equation. I hope all the steps related to this particular question is all clear to you. So let's just move on further towards the further question to clarify this concept a little bit more.